So every single whiteboard looks perfect for this problem. Like absolutely perfect. So well done. Like, I mean, every single one of them. I'm going to go ahead and show you two different ways to graph these, because even though every single whiteboard is perfect, doesn't mean every single student in this room understands how to do this. So let's just make sure that we all know how to do it, right? So that we're all comfortable? So remember, when you're graphing piecewise, this tells you what to graph. So like we're graphing y equals x plus 2 if the domain was restricted to just x is less than 0. Now y equals x plus 2 is a line, normal line, slope of 1, y-intercept of 2. If I was graphing it normally, my graph would look like that. However, this graph is only valid for the x's that are less than 0. So I don't include any values where the x's, notice this is like our x-axis where you're plugging in x's that are bigger than 0. So I don't include any of those. And actually on the y-axis, when x equals 0, I'm going to put an open circle. Why would I put an open circle there? Because it's not equal to there. It's just less than but not equal to. Okay. Then to graph y equals x, we have a domain restriction of x greater than or equal to 0. If I graph y equals x has a slope of 1, y-intercept of 0. It would normally look like this. If I left it like this, would this graph represent a function?
No.
Why not? Fails the vertical line test, right? Okay. So we know that it can't be this because it has to be a function because it's written in function notation. So, and we know that this bottom graph is only valid for x values that are greater than or equal to 0. And we end up with something like that. Now, so method 1, well, there's like 3 methods. One method is if you actually can do the sketch right off the bat in the proper location with the proper graph, right? So that would be like ideal. Method 2 is where you just graph the whole graph and then erase what you don't want, right? There's a third method. And be honest, this is the time where you advocate for yourself. Would anyone like to see the third method? If you're, yes? Okay, good, good, I'm glad. All right, so here's the third method. When you were young, and you learned how to sketch a graph, you started by plotting points. I don't know what you guys, I called this a T-chart when I was growing up. So we had an X and a Y. And back in the day, when you had to graph a line, you could pick any X's you wanted, right? Some teachers forced you, like always pick -2, -1, 0, 1, 2, right? But you could pick any that you want, right? Okay. Now, we can pick any x's that we want as long as the numbers that we put here are less than 0. Pick any 3 numbers less than 0. -2, -3. Good. You also always want to include this number. Even if it's not equal to it, you still include it on your table. So here's why. So when we sketch our graph, first we got to find our y values. So this is y equals x plus 2, right? X plus 2. So we're just taking each x and adding 2. So if x is -1, x plus 2 is 1, 0, -1, 2. So here's what happens. When I go to sketch my graph, I'm going to plot some points. So I have the point -1, 1. -2, 0, -3, -1, and the point 0, 2. All right, you go to this number right here. I kind of like to think of it as like the handoff point where it switches from one graph to the next. So you go to that number right here. First thing you say is, should it be closed or an open circle? And since it's not equal to, it needs to be an open circle. So I'm going to change that to an open circle. And then that's your starting point. You start on that number, and then you just follow your points. So you always start on that like handoff number, and then you just follow the dots. For the next one, we're going to pick x's that are bigger than 0. Tell me 3 numbers that are bigger than 0. 1, 2, and 3. And then, of course, you also want to always include the handoff point, the 0. This is y equals x. So then if x is 1, y is 1. If x is 2, y is 2. 3, 0, right? So you plot your points, 1, 1, 2, 2, 3, 3, 0, 0, and 0, 0 in this case is going to be a closed circle because of that equal to. Start at that point, start at 0, and follow the dots. Okay? So that's just another method if it works for you. Like you can make T-charts, you can plot points, right? Just make sure all your x values are in what it says to be in the interval that it says. I don't know if that helped or not. Did that help? Yeah? Okay. All right. I hope it helped because I have another one for you to try, but first I have to intro the lesson. So today we're doing a lesson. It doesn't have a section number. It's not in your book. It's called Fitting Points and Piecewise Functions. It's a made-up lesson that we are adding into this chapter because we are. So you can give it any number. If you want to call it 3.9, you can. Just know that there's no 3.9 in your book. Yes, Isaac.
Is this going to be on our test?
Yes. Did you guys all hear that question? You know what Isaac just asked? Is this going to be on our test? What I say?
Yes.
Yes. What isn't on your test? Oh, when is your test?
Friday.
Friday the 13th. Right? Okay. Yes. You will need a graphing calculator. Yes. Now, I'm pretty sure the MRC still has some available to check out. Yep. As a matter of fact, after school today, if you need one and you have a minute, I could probably check one out to you right after school.
So I went there and they said like you need a teacher's recommendation. You need a teacher to.
I'll do it. I'll do it for you. Okay. Oh my goodness. So let's see how well you've picked up on how to graph a piecewise. So I have a 3-way piecewise function. Let's just do this on paper. See, individually, do your best. I'm going to walk around. I want to make sure everyone is trying. All right? Everyone needs to be trying this. So 3 different functions, an absolute value, a line, and a parabola. If I'm graphing y equals the absolute value of x, what shape is that graph? A V. So the graph is a V. It doesn't change just because we're restricting the domain. So absolute value of x, which is, by the way, the parent function. So where's the vertex?
0.
0, 0, right? So normally, absolute value of x looks like that. But I only want this for the x's that are less than 1. So I want you to remember, this is the x-axis, right? All these x's, like that's -1, -2, -3. These are all less than 1. 0 is less than 1. There's 1. So I have to cut off any part of the graph where the x value is greater than 1. And then would I put a closed circle or an open circle on 1?
Close. I mean open.
Why open?
Because it's not.
Because it's not an equal to. So the graph, the shape of the graph doesn't change. You're just only including part of it. Whoa. All right. For y equals 2x plus 1, what's nice about lines that are in between two numbers, so at 1, I would be, if I plugged in a 1, what's my y value? 3. So I would start this graph at the point 1, 3 with a closed circle because it's equal to, and then I would end it at 4, 9 with an open circle. 2, 3, 4, 5, 6, 7, 8. I gotta go up here. Because it's not equal to. So it's off my grade, but that's okay. So if you want to make a T-chart, that's fine. Just make sure you only pick numbers from 1 to 4. And then the last one, what shape is the last graph?
Parabola.
It's a parabola. What is the vertex of that parabola?
5, 0.
5, 0, because the parent function y equals x squared has been shifted 5 places to the right. Does everyone understand that? All right. So we move 5 places to the right. There's the vertex of our parabola. Remember, when you're graphing a parabola, if it hasn't been dilated, you go over 1, up 1, over 1, up 1, and then from there, over 1, up 3, over 1, up 3, and then you'd go over 1, up 5, and so forth, except we only want this parabola from 4 to 7. So here's x equals 4, which means that point should not be here. So I have 4, 5, 6, 7. Uh-oh, I don't want to include the 7, so this has to be an open circle. Open circle, and then I graph my parabola. Is that what you got? Ryan, you look excited. Yay! Very good. Okay. Are there any questions? Nithya, how you doing? Yeah? Any questions? Okay. Do you understand the little segment I was showing you that you're missing that little, you had everything right except you're missing this little guy right there. Yeah, Isaac.
The second equation, never mind.
You okay?
Yeah.
Okay. All right. If you feel good about this, let's see if you can do it backwards. So now I've given you the graph, and your job is to figure out the function. Personally, I think this is easier. So you draw yourself a Y with a big open squiggle bracket. You write all 3 equations. Equation, equation, equation. And then next to each equation, you just write the x values, the domain of that function. The x values where it's valid. So take a minute and see what you can do with this. Left, the equation of this line, what's the slope of this line? -1. The y-intercept, if we kept going, would be -7, right? So the equation of this line is y equals negative x minus 7. Is that okay? Are we all okay with the equation? All right. The next one, this parabola in the middle, has it been translated at all? Has it been dilated? No. And the way you know it hasn't been dilated is if from the vertex, if you just go over 1, up 1 to get to a point, then it hasn't been dilated. It's just your normal x squared, right? So this is just y equals x squared. And then the last equation, it's a horizontal line. So what would be the equation of this? Y equals 6. There's our 3 equations. Now we've got to write their domains. So this one on the left is only valid for x's in what interval? You could say, you can actually tell me the interval from something to something. -∞ to -2. Now on your test, we talked about that this morning in our PLC meeting. The other teachers, 2 of the other teachers did not teach any infinities at all. So they are just having their students write x is less than or equal to -2. If you write -∞ less than x less than or equal to -2, that's absolutely fine. But just know that on your test, you're just going to see in the domain of the parabola? Negative 2. What's the highest x value? 2. So do we include the negative 2? No. So to write this, we would put negative 2 less than x less than or equal to 2. Open circle, close circle. Last one. What's the domain of this horizontal line? Beautiful. Yes. Would it be equal to?
No.
No. So you just say x is greater than 2. All right. Any questions? How did we do on that? Are we I'm getting a lot of thumbs up. That's good. Oh, good. Okay, got another one in the back. I like it. All right. We're moving on to the last topic of the whole unit. So here we go. So what I need you to do is get out your calculators. I'm going to make this a little bit smaller and move it over so that I can walk you through this. Okay. All right, let me plug this in. This over. Where are my keys? Okay, so here's what's going to happen. Shh, quiet down, please. We are going to use our calculators. So in life, sometimes we don't get a function. Sometimes we just get a whole bunch of data. And from this data, we have to figure out what function best models the data. So you might have a whole bunch of dots, right? And let's say that like your dots, oh, I can't draw in here. That's right, I have to draw over here. Let's say your dots look like that, right? Pretend for your data. Then what kind of a function do you think would model this data? A parabola, which we would call a quadratic function, an x squared, right? What if your data just looks like that? That would be a line, right? You can have data that is in the shape of pretty much anything, right? So sometimes your data is like really wacky, and then you have to do a bunch of different functions and put them together, and that would be a piecewise. But what we're going to do today is we're going to learn how we're going to use our calculators to figure out the equation of the function that models this data. And that process is called regression. It's called regression. So if you have your calculator with you, turn it on. If you don't have a calculator with you, just look over someone's shoulder. All right. So the first thing that we have to do is enter the data. If you see here under the delete key, you should see a button that says stat. So you're going to hit enter on stat. Then to edit your list, you're going to hit enter on edit. Now I have stuff in here from last hour. Does anyone else have stuff in their lists? Okay, no, all right, I'm just going to clear mine out. I'll teach you how to clear in a minute. Okay, so are you all sitting at like under L1 and it's empty? Okay, what you're going to do is you're going to type all your x values into list 1. So my x values are -5, so I type -5 and I hit enter. Then -2, enter. 1, 4, 9, 12, 16, and 18. Does everyone have the x values entered in? All right, just hit the right arrow to go to the next list. In the next list, you're going to enter all the y values that go with those x values. So we're going to enter 15, 16.2,
17.4, 18.6, 20.6, 21.8. Wait, I gotta put on my glasses, make sure I'm putting it right in. Yep. 24.4, 25.2. You should have one y value next to each x value, and they have to be next to the correct x value. All right, does everyone have their lists entered? If you have a calculator, yes. All right, now we're going to look and see what this graph looks like. The way that you graph, first go to your y equals menu. Everyone just hit y equals. If you have anything in y equals, please hit clear and get rid of it. Yes?
Mine says plot 2. Does that matter?
Oh, like up here?
Yeah.
Not yet. Is it highlighted?
Yeah.
Okay. So you know what you can do to turn it off? Arrow up to plot 2 and just hit enter on it, and that'll turn it off.
All right.
Okay? All right. So now we are going to go into what's called a stat plot. So stat plot, to get there, you hit second and your y equals button. You have multiple stat plots, but we're just going to use plot 1. So I want you to hit enter on plot 1. So what this says, you have an on and an off. You want to hit enter on to turn it on. Everything else is going to stay. This first graph, when it says type, there's different types of graphs you can make from data. This first one is called a scatter plot. That's what we're doing. It's just where you plot the points. It's just a bunch of dots on your screen. Your X's are in list 1. Your Y's are in list 2. So everything stays with the defaults. All right? So as long as you've turned on the plot, you're good to go, unless your defaults have changed. Everyone good with turning on their plot? All right, now we need to graph it. When you're graphing statistics, your window is really important. So the way that we adjust our window, hit the zoom button. And if you look at option 9, 9 says zoom stat. If you hit enter on zoom stat, it will automatically adjust your window to fit all of your little data points. So just hit enter on zoom stat. That means there's a problem with your window. Okay, you entered a value with no y. You have to ask why it doesn't. Oh, so see how the stat line is above? Oh, okay. Did you get all your data? Okay. Yeah.
There we go. Got it. Yay. Okay. All right. What kind of a function do you think this looks like? Looks like a line, right? So we're going to do a linear regression. So what I want you to do now is hit your stat button again. Go back to stat. Arrow over to calc. Under your calc menu in stat, down a little ways, you have LINREG. That stands for linear regression. You also have quadratic regression if you think it looks like a parabola. Cubic regression, which we haven't talked about yet. Quartic regression. You also have logarithmic regression and exponential regression and all the different types of trigonometric regression, all the different types of functions that are out there can model data. For us, we're just going to do linreg or linear regression. So you're going to be on option 4 and you hit enter. It's going to ask you, where are your x's? Our x's are in L1. Our y's are in L2. You don't have to put anything else in. We don't have a frequency list. We don't need to store the regression equation. So you could just hit enter on calculate. And there's our equation. So if we were to write the equation of this line, so it says above it, it says y equals ax plus b. And then it says a is around 0.44. And then b is around 16.97. That's your equation of your line. So if we go ahead, I'm going to just do this. You don't have to do this. I'm going to plot this actual line. So 0.44x plus 16.97. If I actually graph the line, does it look like it models our data pretty well? Yes. So that's what your calculator is doing. It's creating a function that models the data. If you were asked to do this on a test, which you will be, you're going to be given a set of data, and you are going to have to write the equation that models the data. Are you ready to try another one? All right. Let's see. Okay, so to clear your, I'm going to clear my graph by just hitting clear on my graph. If you want to turn off your stat plot, you just hit enter on it and it turns it off. If you want to clear your lists, to go back to your list, you hit stat, hit enter on edit. Quick way to clear a list, arrow up so your cursor is sitting, like see where your cursor is sitting right there on the name of the list, and just hit clear and then arrow down and it'll clear the list. So arrow up on the name, hit clear, arrow down, and the list will be clear. Or you can just sit there and hit delete, 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 delete over and over and delete all the entries. All right, so let's do another one. So this one, so you can make it a tiny bit bigger. So the top row is your x's, the bottom row is your y's. So we have an x of negative 2.93, negative 1.45, 2, 2.93, 4, 5, and 6. For our y's, we have negative 6.005, negative 2.569, 2.25, 2.785, 3, 52.81, and 2.25. Do any of these numbers seem out of place?
52.
The 52.81 seems out of place. We're going to go ahead and graph this just to see what it looks like. So to graph, remember, you probably all have your stat plot still turned on. If you don't, hit second y equals and go like
make sure it's turned on. You just hit enter on on. How do we fit our graph to our data? What do we use to adjust our window? Zoom. And then which option? Zoom stat. And you can just hit zoom and the number 9 and it'll adjust it. All right. So there's our data. So we've got this data right along here. Looks like it kind of goes up and then maybe goes down, except for this point right there, which is like way away from the rest of the data. Does anyone know what we call a piece of data that's like totally different? It's an outlier. Good. Oh, that's good that you guys know that. All right. So we have this outlier. What's going to end up happening if we do a regression equation? Does anyone have an idea, a guess, like what do you think might be a good type of equation for this? Would we do linear? Would we do quadratic? I would do quadratic. It kind of, to me, looks like it's kind of curving up and then starting to go back down again. So we're going to do a quadratic regression. Just know that when we graph it, this outlier is going to pull it up a little bit above the data because of this silly outlier that's up here. So, but that's okay. You got to, do what you got. So everyone see if you can find a quadratic regression equation for this data. So we hit stat, arrow to calc, and then go down to quadratic regression, and then just enter all the way through. So notice the format. This says it's y equals ax squared plus bx plus c. So our equation would be y equals 0.18 x squared plus 2.57x minus 0.5 roughly. Yeah, you can round to maybe 2 decimals. It's fine. So to get to the regression screen, so you hit stat, then you arrow over to calc, and then do you see quad reg? It's option 5. Hit enter on that, and then enter, 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 enter until you're sitting on calculate, right? Hit enter one more time, and it'll give you that screen. All right. By the way, if I wanted to do, like there's a way you can, I'm going to show this to you. I don't know if I should or not, but I'm going to. Say I wanted to store this into my y equals. See where it says store regression equation? I can hit vars, y vars, and just throw it into my y1. And then what'll happen is once it calculates, if I go to my y equals, it'll already be in there. And I don't have to retype it. It's just a little time saver. If I graph this now, there's my regression. It's not very good. Why is it not very good? Because of that silly outlier, right? I think I was missing a piece of data, though. Yeah, we had one more. If I had entered this one more piece of data, I think the parabola would have looked better. But that's okay. All right. This one is huge. This is a bounce of a ball. The ball's going up, the ball's going down. It's very much a parabola. Do we need to do this right now? Are we good? Okay, we're going to do more practice over the next 2 days, but I want to get started on something else. So I'm going to pause this. Can I borrow this for a second? All right, so I wanted to show you something from last night's homework because it was formatted in a way that I had not taught you. All right. So problem number 6, we had y over 7 squared plus x minus 3 over 10 squared equals 1. So when I taught you yesterday standard form, so standard form for an ellipse looks like this. X minus h squared over a squared plus y minus k squared over b squared equals 1. So horizontal shift for your center, vertical shift for your center, and then the square root of this number is how far you go left and right, and the square root of this number is how far you go up and down. This one was different. It's very similar, but it's a little bit different because they put the square root on the whole term. So to convert this to standard form, all you have to do is actually just square the whole thing. So this becomes y squared over 49, and this term becomes x minus 3 squared over 100 equals 1. So just go ahead and apply the squared. And now, if you're now you're back to what we had done yesterday. So like if we were to graph this, they did something else. They're just trying to throw you off. So they put the y first. Sorry. So let's write the x's first. X minus 3 squared over 100 plus y squared over 49. All right. What is the vertex of or what is the center of this ellipse?
0, 3.
Close, not 0, 3, but 3, 0, right? 1, 2, 3. There's your center. I'll get it for you in a minute. Okay, so there's your center. How far from the center am I going to go left and right? 10. It's the number under the x. 10. That's okay. Okay, so dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put a dot. How far up and down? 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then, there's my, pretend that's a good ellipse, right? Anyway, so yesterday in your homework it was presented with the whole thing squared. Don't let that throw you. Just square the top, square the bottom. Write it in with x's first and y's second, and you're back to how we can do it. Yes. Did it say solve for y? I thought it said write it in standard form. Oh, wait. Oh, and then solve for Okay, so if you had to solve this for y, do you want me to show you how to do that?
Yeah.
All right. What was this one, 10? Okay, is that our original equation?
Yeah.
Get y by itself, take this whole term, move it to the other side. So you have y over 7 squared equals 1 minus this whole giant term. Squared. Now what do? Square root both sides. Whenever I square root both sides, what has to go in front of the square root? Plus or minus. And then, what's the last thing I have to do to get y by itself? Multiply by 7. Y equals plus or minus 7 times the square root of 1 minus x minus 3 over 10 quantity squared. There you go.
I have a question. Isn't that slope?
No, because this isn't a line.
Oh yeah. Well,
Yeah.
you said this is standard form.
I would never call this standard form. This is solved for y. I've always known standard form of an equation of ellipse to be that.
Yeah. Someone said standard form.
Yeah. Okay, good. I'm stopping the recording, and then I'm going to give you a quiz.